I've rebuilt my circuit now. Now it looks almost exactly like Jason Nguyen's circuit, except for a couple of differences. One, I'm using the fancy TLC272 op amps for the front end. Everything else is an LM324. I don't have these diodes and resistors on the inputs. Those are just there for safety. But I don't really care about safety. I'm a damn the torpedoes full speed ahead kind of guy. And also I've changed stuff around over here. I've gotten rid of these two resistors and this capacitor here and just connected the plus input of the integrator op amp directly to the minus input of the back end op amp. My reasoning for that is that these two resistors are really doing the same thing as these two resistors right here. They both connect both of the signal lines to a single node, and they sort of do the job of summing both of those signals together at this node. And this op amp, the integrator, is not going to be drawing any current from there, so it won't hurt anything if we just connect it right directly to that. The only potential problem I can see with this is getting rid of this capacitor. I don't really know what that capacitor is doing there, so I'm going to take it out and see what happens. This change is probably going to bite me in the ass later, but I'm going to do it anyway, and at least I'll learn why he built the circuit this way. And correcting the DC offset between the front end and back end does change some other things a bit too. You notice that the back end amplifier is not a differential amplifier anymore. Now it's a summing amplifier, and that's because of the way that the DC offset correction is made. So here we have an integrator that's finding the DC offset and adding it into one of the signals. Now the way it's added in is with this summing amplifier right here, which is an inverting summing amplifier, which means that when the signal comes in at this point in the circuit, the signal we want is differential and the noise is common mode, which means that the signal is encoded in the difference in voltage between the two, and any voltage that these two have in common is noise. But because this summing amplifier here is also an inverting summing amplifier, that means after this amplifier, the signal on this bottom side here is actually inverted, which means that now at this point, the signal is encoded as the common mode, and the noise is differential, which is why the differential amplifier has been switched with a summing amplifier. So instead of subtracting these two signals to get our desired signal out and get rid of the noise, now we have to add them because we've inverted one of them. And that's about all there is to it. That's different from last time. So let's get into it and see how it works. Here's the circuit on a breadboard, just in case you wanted to see it. It's turning into a pretty big mess now, but that's alright as long as it works. So let's get this going now. I have the multimeter in the shot again, showing the output of the integrator, which should show how much DC offset it's subtracting off. So let's get this turned on. So this is mostly here, so that I can see if that output of the integrator is railed, which should show me if I have too much DC offset. So let's go ahead and start recording and see what happens. That's probably radio or something. I can see a little bit of a heartbeat in there, but this thing mostly doesn't want to behave. So even in these spots where I can't record anything and I just get nothing out here, the DC offset is not entirely outrageous, so it's not having its outputs railed or anything. It's probably just a connection problem. I'm going to use some of this conductive jelly and see if that fixes things. Alright, it's looking a bit better, maybe. When I do get some stuff out of it, see the heartbeat signal is a little bit stronger, but it is pretty shoddy. And I can know from what I'm reading off the multimeter that it's not DC offset that's the problem. And whether or not I can actually get a signal seems to be pretty heavily dependent on what I do with these electrodes, so I'm guessing it's mostly a connection problem. Here I've got it going pretty good. Oh, nope, lost it. I had it going pretty good. I'm having a lot of trouble getting this thing to do the same thing twice. Alright, so this clearly isn't working out for me too well. I'm going to stop this and then make some changes and try it again. Since it looks like I've been having problems with connection, I'm going to bring up something that I thought was not too important until now. So I mentioned in an earlier video that the conductive jelly did a pretty good job of cleaning the pennies. Well, it turns out it also does a pretty good job of corroding them. I've just been sort of throwing them away and getting new pennies each time. I haven't been worrying about it, but now that I've got the pennies soldered onto the wires, I do my best to keep them clean, but they still sort of get dingy while I use them. So I'm going to go back to using alligator clips and brand new pennies without the conductive jelly, and see if that solved my connection problems. So it turns out that my alligator clips are also a little bit horribly corroded. So I gave up on that and soldered some brand new shiny pennies onto my wires. And I'm not going to be using the jelly from now on, so hopefully this should work out a little bit better. Alright, I'm still having the same sorts of connection problems, so that pretty clearly wasn't the problem. But it looks like the DC offset tracking circuit works. So I think the thing to do now is to undo all the changes that I made to Jason Nguyen's circuit so that it's exactly like his, and then hopefully that will work. That should give me an idea of why he had those extra resistors and capacitor in there. And if it doesn't, then I guess I have something else to debug. While I was moving my electrode cable around, one of my pennies just sort of fell right off. I guess I'd cut it a little bit too much when I was stripping it. So now I'm resoldering all the pennies on and being extra careful when I strip it. And also using one of these binder clips to hold the wire down on the penny so that it doesn't move around while the solder's cooling. And hopefully this will give me a better connection. So I'm going to try this out again before I switch the circuit around. And then if this doesn't work, I'll change the circuit back to the original. I've messed around with the electrodes a bit and gotten it to look a bit more stable. I also moved the multimeter to show the output of the entire circuit instead of the output of the integrator, which shows that I still have the DC offset flying all over the place. It should be staying around 0 if that integrator is doing its job. We can see pretty clearly that it's not. And if I push on the electrodes just right, I can actually rail the output of the circuit so they don't get any signal. So it looks like my problems might not be connection related, and when I was pushing on the electrodes and thinking it was changing the connection, it was actually changing the DC offset. So it looks like now I have to look back into that DC offset tracking circuit to try and figure out what went wrong there. Alright, now I've gotten rid of that modification that I made to Jason Nguyen's original circuit, and it's working a lot better now. Yeah, so it turns out that change that I made actually did come back and bite me in the ass. The multimeter there showing the DC offset of the output, I can still change it around quite a bit by messing around with these electrodes, but it stays pretty stable. To be honest, I'm not sure if the problem was because of the modification that I made, or if I just had it put together wrong and accidentally fixed it when I switched the circuit back over. There was this capacitor here at the input of the integrator. I'm going to take that out and see what happens. Well, it looks like that wasn't it. And now I'm going to take a wire and just short together those 2 points in the circuit that I had together originally. So this point here in the circuit, I'm going to be shorting into this part of the circuit, which means it'll then be basically exactly the same as I had it before. And we'll see if that breaks it. If that doesn't break it, then that means I just had it put together wrong the first time. And you can tell by that DC offset that that actually was the problem. So if I take that wire back out again and disconnect those 2 points in the circuit from each other, everything works just fine. Well, except for all that noise that's on there. The point is that the DC offset isn't running away and there's still a heartbeat on there. And now that I look at this again, I see exactly what happened there. Turns out that was just a completely stupid thing to do. So I had said that this resistor divider here is going to be the same as this voltage divider over here, so I might as well connect them together. Problem is, it's not, because it's connected to this input of the op-amp. The op-amp is going to try to make the voltage here equal to the voltage at the plus input here, which means that the voltage here is always going to be stuck at VDD over 2, which is my ground reference voltage. So this integrator is not going to be seeing any of the DC offset, so it's not going to be subtracting any off, and the DC offset stays. That was kind of an embarrassing mistake. You probably caught that and started yelling at your computer screen. What are you doing, Schuster? You ding-a-ling? You can't connect those 2 points together, it won't work. Well, don't worry, I figured it out. Stupid mistakes are what my channel's all about. So clearly I'm going to need some more filtering on the front end to get rid of that radio before it even gets into the amplifier. I also want to modify the DC offset correction again. I'm just going to try one more thing with it and then I'll move on. So even though there's still a bunch of radio on there, this is still the most reliable I've seen this thing work. And it only took 1 or 2 or 5 or 6 embarrassing mistakes to get to this point. I think this would be a good point to stop the video and I'll do that one more change to the DC offset correction in the next video. Then after that, I'll finally get around to removing all that noise.